We find ourselves surrounded by infinity, or so we believe. Consider the simplest act imaginable: counting. 1, 2, 3, 4. Every child learns this. Every adult takes it for granted. The numbers stretch ahead endlessly, a staircase climbing forever into the mathematical dark. We are taught this is natural, obvious, unremarkable. The counting never stops. Infinity waits at the end of every sequence, patient and eternal. But here's the peculiar thing. Look around you, right now, wherever you are. Point to something infinite. Go ahead. I'll wait. You cannot do it. Every object you see has edges. Every room has walls. Every book has a final page. Every planet has a surface you could, in principle, walk around. Every galaxy, however vast, contains a countable number of stars. The universe itself, seemingly the best candidate for infinity we possess, appears to have a finite age, possibly a finite size, and almost certainly a finite amount of information. Infinity is everywhere in our language and nowhere in our experience. This gap between what we say and what we encounter is not a minor discrepancy. It is a clue. Perhaps the most important clue we have about the nature of reality itself. We use the word infinity casually, the way one might use love or freedom, as though its meaning were self-evident, its existence beyond question. Infinite universe, infinite possibilities, infinite potential. The word tumbles from our mouths like loose change spent without counting. But what if we paused to examine this currency we so freely spend? What if actual infinity, not the mathematical shorthand, not the poetic flourish, but a real, physical infinity existing in nature, were not just absent from our experience, but forbidden by the very structure of the cosmos? Consider for a moment how you learned about infinity. The numbers continue, you were told. They go on forever. And so they do, in the sense that our notation system never runs out of symbols. We can always add one more. We can always write another digit. But ask yourself, the numbers continue into what? Into nothing physical, it turns out. The counting continues because we designed it to continue. We invented a method that never exhausts itself. This tells us something marvelous about human ingenuity. It tells us nothing whatsoever about cosmic structure. The endlessness is in our method, not in nature. We invented infinity. We did not discover it. This distinction matters more than you might expect. The universe we actually inhabit appears finite in every measurable respect. It has a finite age, approximately 13.8 billion years since the Big Bang, a number derived from multiple independent observations and verified beyond reasonable doubt. It contains a finite amount of matter and energy, vast beyond human comprehension, certainly, but not infinite. It may well have a finite spatial extent, though this remains an open question. Even when we look at the largest scales we can observe, we find finitude. The observable universe has a radius of roughly 46 billion light-years. This is not infinite. It is merely very, very large, large enough that our minds struggle to grasp it, but nowhere near infinite. The difference between very large and infinite is not a matter of degree. It is a difference in kind, as fundamental as the difference between something and nothing. So why do we speak as though infinity were ordinary? The answer, I suspect, lies in the linguistic trap we have set for ourselves. We say infinite when we mean more than I can count. We say endless when we mean continuing beyond my attention span. We use infinity as an intensifier, the way we use very or extremely, draining the word of its actual meaning until it becomes mere decoration. This domestication of infinity makes it feel familiar, safe, comprehensible, but the feeling is an illusion. Genuine infinity is none of these things. Genuine infinity is deeply, disturbingly strange. So strange that its strangeness should alert us to the possibility that it does not, in fact, describe anything real. There is a simple test you can perform. Sit quietly for a moment and attempt to imagine something truly infinite. Not merely large, but genuinely without boundary. Not a very long line, but a line with no end. Not an enormous collection, but a collection you could never finish counting, no matter how long you counted. You will find your mind either gives up or substitutes very large for the genuine article. We cannot picture infinity. We can only gesture toward it with words. And perhaps this inability is not a limitation of human imagination, but a clue about reality itself, a sign that our minds, evolved to navigate a finite world, correctly intuit that infinity is not among the things that exist. The question is, if infinity is so absent from experience, so foreign to intuition, why does it appear so prominently in our mathematics and physics? And more troublingly, what are those mathematical infinities actually telling us? To understand why infinity is not merely strange, but genuinely problematic, we must visit a hotel. Not an ordinary hotel. Those fill up and turn guests away, as anyone who has arrived late to a popular destination knows. No, we must visit Hilbert's Hotel, named after the mathematician David Hilbert, who constructed it specifically to expose infinity's absurdity. Imagine a hotel with infinitely many rooms, numbered 1, 2, 3, and so on without end. Every room is occupied, a full house. Now a new guest arrives at reception, hoping for accommodation. In any ordinary hotel, the answer is simple and final. Sorry, we're full. But Hilbert's Hotel is not ordinary. The manager makes an announcement over the intercom. Every guest must move to the room with the next higher number. The guest in room 1 moves to room 2. The guest in room 2 moves to room 3. The guest in room 3 moves to room 4. And so on, forever. When the shuffling is complete, room 1 stands empty. The new guest checks in. The hotel was full before this operation. It is full after. Capacity has been created from nothing. Or rather, capacity has been revealed as a meaningless concept when applied to infinite collections. But wait, it gets worse. Suppose an infinite busload of new guests arrives. Passengers numbered 1, 2, 3, and so on, each hoping for a room. Surely this is impossible. The hotel is already full. But the manager has another trick. Each current guest is asked to move to the room with double their current number. The guest in room 1 moves to room 2. The guest in room 2 moves to room 4. The guest in room 3 moves to room 6. Now all the odd-numbered rooms, 1, 3, 5, 7, and so on forever, stand vacant. Infinitely many rooms have materialized from a hotel that was already full. The infinite buzzload checks in without incident. You might smile at this as a clever paradox, a mathematician's party trick, the sort of thing that makes for entertaining conversation at dinner parties. But its implications are not entertaining at all. They are devastating. In a world containing actual infinities, the basic arithmetic we rely on collapses. Infinity plus 1 equals infinity. This is not a simplification. It is literally true of infinite collections. You can add to them without making them larger. Infinity minus infinity can equal anything you like. 0, 7. Another infinity. The operation becomes undefined, undetermined, meaningless. Half of infinity equals infinity. The even numbers are half of all the counting numbers, yet there are just as many of them. These are not paradoxes to be cleverly resolved. They are logical consequences that follow necessarily from the premise. The premise itself is what fails when applied to physical reality. The question is, why does this matter beyond the amusement of mathematicians? It matters because physics depends entirely on the operations that infinity breaks. Every scientific prediction requires comparing possibilities. Every probability calculation requires counting outcomes. Every measurement requires determining quantities. When infinite options exist, these operations become meaningless. You cannot compare infinite collections in the ordinary way. You cannot assign probabilities to infinitely many equally likely outcomes. The mathematics simply breaks. This is why, when physicists encounter infinity in their equations, they do not celebrate the discovery of something infinite. They worry. They recognize the infinity as a symptom, a warning sign that something has gone wrong. Consider what happens when you divide any number by 0. Your calculator returns an error. Mathematicians say the result is undefined. This is not because nature contains undefined things, but because division by 0 is a meaningless operation, a question posed in a form that cannot yield a sensible answer. Infinities in physics function similarly. They are the mathematical equivalent of dividing by 0. Signs that we have asked to question our equations cannot properly answer, or pushed our theories into a regime where their assumptions fail. The infinities in quantum field theory plagued physicists for decades. Electrons interacting with their own electromagnetic fields produced infinite energies. Clearly nonsense, since actual electrons have finite, measurable mass and charge. The solution, called renormalization, was essentially a sophisticated form of sweeping infinities under the rug, a mathematical procedure that cancelled infinite quantities against each other to produce finite, testable predictions. It worked beautifully. But many physicists remained uncomfortable. Richard Feynman, one of its inventors, called renormalization a shell game and hocus pocus. The technique succeeded without satisfying. The infinities were managed, not understood. And this is the crucial point. When we read in popular science that the Big Bang began with infinite density, or that black holes contain points of infinite curvature, we should not understand these as descriptions of nature. We should understand them as confessions, admissions that our best theories have encountered their limits, that the equations are telling us something has gone wrong. The infinity is not in nature. The infinity is in the theory, marking the place where understanding fails. Consider any prediction you rely on. Weather forecasts, medical diagnoses, economic projections, each depends on finite calculations comparing finite possibilities. Imagine trying to predict tomorrow's weather if infinitely many atmospheric states were equally possible. You couldn't. Probability would collapse. Prediction would become impossible. The fact that forecasting works, imperfectly, yes, but genuinely, is evidence that reality is finite. The fact that physics works at all is evidence that actual infinities do not exist. If infinity breaks the machinery of reasoning, how does the universe avoid it? The physics seems to point toward infinity at the Big Bangs, at the centers of black holes, at the foundations of matter. Yet somehow reality sidesteps these apparent endpoints. How does it manage this trick? Here is the insight that transforms understanding. Something can be finite in extent, yet have no boundary whatsoever. This sounds like wordplay. It is not. It is geometry. Consider Earth's surface. You can travel in any direction, north, south, east, west, without ever encountering an edge. No wall stops you. No boundary marks the end of the world. In this sense, Earth's surface is unbounded. You could walk forever without running out of surface to walk on. Yet Earth's surface is also finite. It has a definite area, roughly 510 million square kilometers. If you tried to paint it, you would need a finite amount of paint. You could, in principle, tile it with a finite number of tiles. The surface is finite but unbounded, limited in extent, yet lacking any boundary or edge. This is not a contradiction. This is not a trick of language. This is simply what certain geometric structures are like. Now apply this insight to a question that has haunted humanity for millennia. If the universe began with the Big Bang, what came before? This question seems to demand infinity somewhere. Either time stretches back infinitely, an infinite past with no beginning, or time begins at some first moment that requires an external cause. What caused the cause leads to infinite regress. Nothing caused it seems to violate the principle that everything has a cause. But there is a third possibility. Imagine time as a direction, like north on Earth's surface. As you travel north, eventually you reach the North Pole. What lies north of the North Pole? Nothing. Not because there's a wall, not because you've hit the edge of the Earth, but because the question makes no sense. The concept of north simply doesn't apply at the pole. You can travel no farther north because north has ceased to be a valid direction. The direction ends, but there is no boundary there. This is what the no-boundary proposal suggests about time. As we trace time backward toward the Big Bang, we may reach a point analogous to the North Pole, a point where the concept of before ceases to apply, not because something blocks us, but because the geometry of space-time itself closes off, like the surface of a sphere. The question, what came before the Big Bang, may be like asking for directions to Earth's edge on a spherical planet. The question presupposes a structure that reality does not have. It is not that the question is too hard to answer. It is that the question is malformed, based on assumptions that turn out to be false. This is a profound shift. For most of human history, we have assumed that time must either go back infinitely or begin at some first moment requiring explanation. The no-boundary proposal reveals that these are not the only options. Time can simply round off. Near the Big Bang, under conditions of unimaginable temperature and density, something remarkable happens. The distinction between time and space grows fuzzy. Time acquires characteristics we normally associate with space, and space, as we know, can curve back on itself. If time can behave like space near the Big Bang, then time can curve back on itself, the way a sphere's surface curves back on itself. The beginning of time becomes like the North Pole, a point, yes, but not an edge, not a boundary requiring something on the other side. The implications are extraordinary. In this picture, the universe is self-contained. It needs no external cause. It requires no moment before the beginning, no creator to light the blue touch paper, no first domino that must itself be pushed. The universe simply is, finite in age, possibly finite in size, yet lacking any temporal boundary. The infinity that seemed to lurk at the origin, the infinite density, the infinite temperature, the singularity where all our equations break down, dissolves. It was never a feature of nature. It was an artifact of asking the wrong question. When we asked, what happened before the beginning, we assumed that before meant something. The no-boundary proposal suggests it doesn't, not because time is infinite, but because time closes off the way Earth's surface closes off. There is no before, because before is not a valid direction from that point. The ancient puzzle of infinite regress, what caused the cause that caused the cause, dissolves. Not because we've found a first cause, but because the very structure of space-time eliminates the need for one. This is not evasion. This is not explaining away the question. This is a genuine answer, one rooted in geometry, in physics, in careful mathematical reasoning about the nature of space and time under extreme conditions. The universe avoids infinity at its origin, not through some special mechanism, but through its very shape. Finite, but unbounded. Limited, yet edgeless. This is how reality threads the needle between infinite past and inexplicable first moment. This is how the cosmos begins without beginning. But this raises a further question. The origin of time may avoid infinity through elegant geometry. But what about black holes, where matter collapses to alleged singularities? What about the infinities that plague our quantum theories? Does the universe avoid infinity everywhere? And if so, what does this tell us about the nature of existence itself? Black holes are among the most dramatic objects in the cosmos. Matter collapses under its own gravity until nothing can stop it. Not the pressure of electrons repelling each other, not the nuclear forces that hold atoms together. The collapse continues until everything is crushed to a single point of allegedly infinite density. Or so the popular story goes. But here's the strange thing. The physicists who study black holes most carefully do not believe in these singularities. They recognize them for what they are, symptoms of incomplete physics, not features of nature. The mathematics predicting singularities comes from general relativity, Einstein's magnificent theory of gravity, perhaps the most beautiful and successful theory in all of physics. General relativity has been confirmed by experiment after experiment. It correctly predicts the bending of light by gravity, the precession of Mercury's orbit, the existence of gravitational waves. But general relativity has a limitation. It treats space-time as smooth and continuous, infinitely divisible, with well-defined positions at every scale, no matter how small. This works wonderfully for planets and stars and galaxies. It fails catastrophically when matter is compressed to the smallest scales. Why? Because at the smallest scales, quantum mechanics takes over. Imagine pressing a photograph's zoom function indefinitely. At first, you see clearer and clearer detail. But eventually, you no longer see finer features, you see the pixels. The smooth image breaks down because smoothness was never truly in the data. It was a large-scale appearance, an average over many pixels. Zoom in far enough, and the granularity reveals itself. General relativity treats space-time as smooth, but at extremely small scales, the Planck length, roughly 10 to the power of minus 35 meters, quantum effects create something like pixels. Space-time becomes grainy, uncertain, subject to fluctuations that prevent true points from existing. A singularity is, by definition, a true point, a position with no size, no extent, no spatial dimension at all. But quantum mechanics says, at the smallest scales, position itself becomes fuzzy. You cannot pinpoint a location with unlimited precision. Uncertainty is built into the fabric of reality. If positions cannot be precisely defined at small scales, then points cannot exist at those scales. And if points cannot exist, singularities cannot form. The infinity we calculate at black hole centers is not a feature of nature. It is a symptom of using the wrong theory, of applying a smooth space-time theory to a regime where space-time is not smooth. What actually lies at a black hole's center remains genuinely unknown. It is one of the great open questions in physics, requiring a theory of quantum gravity we do not yet possess. But unknown is very different from infinite. General relativity, pushed beyond its domain of validity, produces nonsense, infinite density, infinite curvature, points where time stops. Quantum mechanics steps in to say, these infinities are not real. They are artifacts. They are the theory's way of admitting its own limitations. This pattern repeats throughout physics. When calculations produce infinity, physicists do not conclude that infinite things exist. They conclude that something has gone wrong with the calculation. They look for better theories, more careful methods, ways to extract finite, testable predictions from equations that have misbehaved. The infinity is a message. It says, your description breaks down here. Look deeper. Black holes remain mysterious objects, perhaps the most mysterious in nature, but they are mysterious in the way that unexplored territory is mysterious, not in the way that impossibility is mysterious. What happens inside them is unknown because we lack the physics to describe it, not because infinite density is an actual feature of the physical world. The singularity is a signpost pointing toward missing knowledge. It is not a portal to infinity. Even if singularities did exist, even if there were genuine points of infinite density lurking somewhere in the cosmos, we could never observe them. This is not a limitation of our telescopes. It is a law of physics. Every singularity that might exist is hidden behind an event horizon, a boundary in space-time from which nothing can escape. Not light, not information, not any signal whatsoever. Whatever happens inside a black hole stays inside a black hole, forever sealed away from the rest of the universe. This is called cosmic censorship, and it is one of the most remarkable features of how nature appears to be structured. Consider a hospital quarantine. Dangerous pathogens are isolated behind barriers, not destroyed, but contained. They cannot infect the general population because they cannot escape the quarantine zone. The rest of the hospital continues functioning normally, safe from the contained danger. Event horizons function similarly. Whatever strangeness occurs inside a black hole, singularity or otherwise, remains locked away, unable to influence the universe outside. The cosmos has built walls around its most extreme phenomena. Why should this be? Imagine if singularities could be naked, exposed to the rest of the universe, not hidden behind event horizons. A point of infinite density, capable of exerting gravitational influence on surrounding matter, would make prediction impossible. Physics would break down not just at the singularity itself, but everywhere the singularity's influence could reach. Chaos would propagate outward. By hiding singularities behind event horizons, the universe preserves the finitude that physics requires. The potentially infinite is quarantined. The finite cosmos outside remains comprehensible. Is this coincidence, necessity, deep principle? We do not know. The cosmic censorship hypothesis, the conjecture that nature forbids naked singularities, remains unproven. There is no mathematical demonstration that all singularities must be clothed in event horizons. Yet every black hole we've observed obeys this rule. The evidence, purely photographic, is striking. We have now photographed black hole event horizons directly, the shadow of the event horizon against the bright gas swirling around it. We see only the outside. The inside remains forever hidden, as if the universe has deliberately placed these phenomena beyond observation. Every gravitational wave detector, every photograph, every observation we make shows us only the event horizon, never the interior. And this is not a technological limitation we might someday overcome. It is physical law, as fundamental as the speed of light. Whatever is inside cannot get out. Whatever might be infinite is permanently sealed away. The universe appears structured to forbid actual infinity from influencing physical reality. At its origin, the no-boundary proposal suggests time rounds off, rather than beginning at an infinite singularity. Inside black holes, potential singularities are quarantined behind event horizons. In our quantum theories, infinities arise only as symptoms of incomplete description, dissolved by better mathematics. A pattern emerges, and patterns in physics often reveal something deep about the nature of existence. If the universe systematically avoids infinity, at its origin, in its black holes, in its fundamental laws, then we must ask why. What is it about infinity that the cosmos forbids? What would be at stake if actual infinities existed? The answer, as we shall see, touches on the very possibility of physics itself and the remarkable fact that we, finite creatures, can comprehend the universe at all. We have seen how the universe avoids infinity at its origin, how it quarantines potential infinities behind event horizons, how the infinities in our equations mark the limits of theory rather than features of nature. But we have not yet asked the deepest question: why? Why should the cosmos be so allergic to the infinite? The answer lies in understanding what physics actually is and what it requires to function at all. Consider the simplest act of prediction. You wake in the morning and glance at the weather forecast. A small icon on your phone tells you, rain this afternoon, sun tomorrow. This prediction, humble as it seems, represents one of humanity's greatest achievements. We have learned to anticipate the future. But how does prediction work? At its heart, every forecast depends on comparing possibilities. The weather system could evolve in many different ways. Meteorologists calculate which evolutions are more likely, which less likely, and report the most probable outcome. This requires counting and comparing, weighing alternatives, assigning probabilities, determining which possibilities deserve attention and which can be ignored. Now, imagine trying to make a prediction when infinitely many possibilities exist. What is the probability of rain if infinitely many atmospheric states could produce rain and infinitely many could produce sunshine? How do you compare infinite collections? How do you say one infinite set is larger than another, or more probable than another? You cannot. Not in any straightforward way. The mathematics of probability breaks down when infinity enters. Here is a thought experiment that reveals the problem starkly. Imagine rolling a die with infinitely many faces, numbered 1, 2, 3, and so on forever. What is the probability of rolling a 6? If each face has equal probability, then that probability must be 1 divided by infinity, which is 0. Every individual outcome has probability 0. Yet something must come up when you roll the die. How can every possibility have 0 probability, yet one of them certainly occur? This is not a paradox to be cleverly resolved. It is a demonstration that probability, the foundation of all scientific prediction, requires finite possibility spaces. Alternatively, suppose the probabilities are not equal. Some faces are more likely than others. But then what determines the probabilities? You need some rule assigning different weights to different outcomes, and that rule must ensure the total probability adds to 1. With infinitely many outcomes, constructing such a rule becomes either impossible or arbitrary. Physics works because it can make predictions. Experiments confirm theories. Engineers build bridges that stand. Doctors prescribe treatments that heal. Weather forecasts are more accurate than random guesses. All of this depends on the machinery of probability, on comparing possibilities, on finite calculations producing useful results. If actual infinities existed in the physical world, this machinery would grind to a halt. Prediction would become impossible. Physics would become impossible. This is not a minor technical difficulty. It is the reason finite universes can contain minds that do science, and infinite universes cannot. Consider what we have accomplished. We have deduced the age of the cosmos, 13.8 billion years, from the faint glow of ancient light. We have detected gravitational waves from black holes merging a billion light-years away. We have predicted the existence of particles decades before detecting them. We have built technologies that work, theories that predict, models that match observation. All of this is evidence. Evidence that probability functions. Evidence that finite calculations describe reality. Evidence that actual infinity is absent from the physical world. Our very ability to understand the cosmos is proof that the cosmos can be understood, which requires that it be finite. This reasoning may seem circular, but it is not. We are not assuming finitude and then claiming to prove it. We are observing that physics works, that prediction succeeds, that probability has meaning, and inferring from these observations that the underlying reality must be finite. The success of science is the evidence. Finitude is the conclusion. If the universe contained actual infinities, beings capable of recognizing this would never arise. Physics would not function well enough to produce brains. Evolution would not navigate infinite possibility spaces. Complexity would not emerge from chaos. We exist. We comprehend. Therefore, the universe is finite. This is perhaps the most elegant argument against infinity. Its existence would preclude the existence of anyone capable of discovering it. If the universe is finite, how finite is it? Is there a number, an actual number, that captures reality's extent? The answer, remarkably, is yes. Consider a region of space, any region. How much information can it contain? You might think, surely there is no limit. Pack in more particles, arrange them in more complex patterns, encode more data in their positions and motions. Surely you can always cram in a bit more, but physics says otherwise. The holographic bound, derived from the thermodynamics of black holes, establishes a maximum information content for any region of space. And the remarkable thing is this: the maximum depends not on the volume of the region, but on its surface area. This is deeply counterintuitive. Volume seems like the natural measure of capacity. A larger box should hold more things. A bigger room should store more furniture. Yet when it comes to fundamental information content, surface area wins. The reason connects to black holes. A black hole of a given size has a certain entropy, a measure of the information required to fully describe its internal state. That entropy is proportional to the surface area of the event horizon, not to the volume it encloses. This suggests something profound. The maximum information that can exist in any region is bounded by the area surrounding it. The universe has a resolution limit. Reality has grain. For the observable universe, this maximum works out to approximately 10 to the power of 122 bits. That number deserves contemplation. 10 to the power of 122 bits. A 1 followed by 122 zeros. More than the number of atoms in the observable universe. More than the number of seconds since the Big Bang. more than any quantity you have encountered in ordinary life, by many orders of magnitude. And yet, it is finite. There is, in principle, a longest possible book that completely describes the observable universe. It would be inconceivably vast. No library on earth could hold it. No computer could process it. No mind could comprehend it. But it would have a last page. Everything that exists, every particle position, every quantum state, every fact about the cosmos, all of it is encodable in a finite string of bits. Incomprehensibly many bits, yes, but not infinitely many. This transforms our picture of reality. Think of the universe as a hard drive with maximum capacity. You can store vast amounts of data, more than you could process in 1 trillion lifetimes. But there is a limit. The drive cannot hold infinite files. The cosmos cannot contain infinite information. This is not a technological limitation. It is not that our instruments lack the precision to detect infinite detail. There is no infinite detail to detect. At some scale, reality bottoms out. There are no further facts to uncover, because information itself has a maximum density. Every measurement you make, every perception you have, encodes finite information. The sharpness of your vision, the precision of your instruments, the detail in your observations, all constrained by fundamental bounds. Not by our technology, by physics itself. When you look at the night sky, you are seeing finite information arranged in finite patterns. The universe, for all its apparent vastness, is a finite structure. Extraordinarily large, yes. Extraordinarily complex, yes. But fundamentally countable. This should not diminish our wonder. If anything, it should deepen it. The cosmos accomplished everything we observe. Stars, galaxies, planets, life, consciousness, understanding, using finite resources. It did not require infinity. It did not need unlimited capacity. Everything that exists emerged from a finite beginning with finite information. Finitude is not poverty. Finitude is sufficiency. The universe had enough, just enough, to produce beings capable of comprehending it. And this raises the final question. What does finitude mean for us? Not as physicists studying abstract cosmology, but as finite beings living brief lives in a finite cosmos? We have spent most of this journey dismantling infinity, exposing its strangeness, showing its absence from experience, demonstrating why physics forbids it. But we have not yet asked what may be the most important question of all. What does a finite universe mean for the beings who inhabit it? The answer I want to suggest is not loss. It is liberation. Consider what meaning requires. Think of a sunset. The light fades, the colours shift, and for a few minutes the sky blazes with impossible beauty. What makes this beautiful? What gives it the power to stop us in our tracks, to make us pause whatever we were doing and simply look? The sunset will end. The light will fade. Tomorrow may bring clouds. This particular configuration of atmosphere and light will never occur again in exactly this way. The sunset is precious because it is finite. Now imagine a sunset that lasted forever. The same colours, the same light, unchanging through eternity. Would it still be beautiful? Would you bother to look? A sunset that never ends is not a sunset at all. It is wallpaper. The beauty depends on the ending. This is not merely poetic observation. It is a fundamental truth about meaning itself. Things matter precisely because they are bounded. A first kiss, a final conversation, a moment of unexpected grace. These have weight because they cannot be infinitely repeated, because they occupy a singular position in the finite span of a life. If you could kiss someone an infinite number of times, if conversations never ended, if moments recurred eternally, the very concepts of first and final and singular would dissolve. And with them, meaning would dissolve too. Consider choice itself. Imagine a restaurant menu with 7 items. You can survey the options, weigh your preferences, consider your appetite, and select with confidence. The choice is meaningful because the alternatives are bounded. You will have this meal, not that one. This matters because not that one actually excludes something. Now imagine a menu with infinitely many items. You cannot survey them. There are too many. You cannot compare them. Infinite options cannot be weighed. You cannot rationally choose. Any selection is infinitely outnumbered by alternatives. Unlimited options is not freedom. It is paralysis. It is the destruction of choice itself. Finitude makes choice possible. Boundaries make decision meaningful. Limits are not constraints imposed on freedom. They are the very structure that freedom requires. Now consider death. We speak of eternal life as though it were self-evidently desirable. To live forever, to escape the shadow of mortality, to persist unchanged through endless time. This is heaven, we are told. This is what we should want. But genuine eternity is another name for infinity. And infinity carries the same pathologies in time that it does in space or quantity. An infinite life would be one in which every possible experience is had infinitely often. Every book read an infinite number of times. Every conversation repeated endlessly. Every meal, every sunrise, every gesture of love, occurring without limit, without rarity, without the meaning that scarcity confers. In an infinite life, nothing would be a first experience, because everything would have infinite precedence. Nothing would be a last experience, because everything would have infinite successors. Nothing would be significant, because significance requires that alternatives be excluded, and in infinite time, nothing is truly excluded. Everything happens eventually. Everything happens infinitely often. This is not heaven. This is a kind of hell, the annihilation of meaning through endless repetition. Death is part of the finite universe. Mortality is what gives time its weight, its direction, its preciousness. Each moment matters because the supply of moments is limited. Each day is significant because the number of days is bounded. We grieve death because we understand that the deceased cannot be replaced, that their particular configuration of memories and hopes and quirks will never occur again. In an infinite universe, nothing would be irreplaceable. Nothing would be unique. Nothing would matter. Finitude is not the enemy of meaning. Finitude is the source of meaning. This reframes everything we might feel about living in a bounded cosmos. We have not been cheated of infinity. We have been given something far more valuable, a universe where rarity exists, where significance is possible, where things matter because they end. The finite universe is not a lesser universe. It is the only kind of universe in which wonder is possible, because wonder requires edges, boundaries, the recognition that we stand at the limit of what can be known or experienced. Infinity offers nothing but more of the same, forever. Finitude offers something infinitely more precious, the unrepeatable moment, the bounded life, the meaning that mortality makes possible. We have arrived at the end of a journey. But where exactly have we arrived? We began by searching for infinity and found it nowhere we looked. The numbers climb forever, but the things we count are always finite. The equations sometimes blow up to infinity, but this marks their failure, not nature's. The universe is staggeringly large, staggeringly old, staggeringly complex, but apparently finite in every measurable respect. The cosmos avoids infinity at its origin through elegant geometry. It quarantines potential infinities behind event horizons. It enforces maximum information density. It is structured from deepest principle to forbid actual infinities from corrupting the finite physics that makes prediction and existence possible. And here we stand, finite creatures in a finite cosmos. But here is the remarkable thing, the strange privilege. We can conceive of infinity. Our finite brains, composed of a finite number of neurons firing finite electrical signals, can somehow grasp a concept that has no physical instantiation. We can define infinity rigorously. We can prove theorems about it. We can explore its mathematical properties, distinguish different sizes of infinity, construct elaborate theories about infinite sets and infinite spaces and infinite processes. And none of it exists. We are infinity's witnesses, but not its examples. Think about what this means. Somewhere in the history of the universe, matter arranged itself into patterns capable of contemplating what matter can never instantiate. Finite neural processes learn to gesture toward the infinite, to hold it in thought, manipulate it in mathematics, reason about it in philosophy, while remaining forever bounded by the finite. This is the peculiar position of intelligence in the cosmos, able to imagine what cannot exist, to reason about what can never be real. Consider a character in a novel who becomes aware they are a character, finite, bounded by the pages of the story, unable to escape the narrative in which they exist. Yet suddenly they can imagine other stories. They can conceive of authors beyond their author, books beyond their book, worlds beyond their world. They cannot visit these places. They will never touch these other stories, but they can think them. We are in a similar position. The universe that produced us is finite. Every measurement we can make, every observation we can record, every calculation we can perform stays within the boundaries of what finitely exists. We cannot instantiate infinity any more than a character can escape their book. And yet, we can think it. We can reason about it. We can hold in our minds concepts that our universe will never contain. What does this say about minds? What does this say about the universe that produced them? Perhaps this: the cosmos is not just finite, but generatively finite. It is finite in a way that produces beings capable of transcending it in thought while remaining embedded in it physically. The universe dreams the infinite through us, uses our finite brains to contemplate what it cannot physically become. The contemplation itself is a kind of miracle. That we can understand the cosmos at all is remarkable. That we can understand its finitude is extraordinary. That we can then conceive of infinities it does not contain. That we can think beyond the boundaries of what is. This is the strangest fact of all. We are just an advanced breed of primates on a minor planet orbiting an ordinary star in one of 100 billion galaxies. But we can understand the universe. We can grasp its structure, deduce its history, contemplate its boundaries. We can think what it cannot be. That makes us something very special. The universe did not need infinity to produce stars and planets and oceans and life. It did not need infinite resources or infinite time or infinite complexity. It accomplished everything we observe, everything we are, with finite means. Finitude was sufficient. Finitude was enough. And finitude produced this: beings who can look up at the night sky and comprehend what they are seeing. Beings who can count the stars, not all of them, but in principle, because the stars are countable. Beings who can grasp their own mortality and find in that very limitation the source of meaning itself. We have been given just enough universe to wonder at, and no more. This, I suspect, is precisely the point. Look up at the stars tonight. There are not infinitely many of them. The observable universe contains perhaps 200 billion trillion, a number so large it defeats imagination, yet still a number, still countable, still finite, and therefore precious. Each star is rarer than it would be in an infinite cosmos. Each galaxy matters more than it could if galaxies were unlimited. The particular arrangement of matter and energy that produced you, this specific configuration of atoms capable of contemplation, will never occur again. You are not diminished by your finitude. You are constituted by it. The boundaries that define you, in space, in time, in complexity, are not limitations imposed from outside. They are the very structure of what you are. Without them, you would not be you. Without them, nothing would be anything. Finitude is not poverty. Finitude is elegance. Finitude is the condition for meaning, for value, for wonder, for existence itself. The universe had just enough to produce minds that could comprehend it, just enough to generate wonder, just enough, and no more. We find ourselves in a cosmos that forbids infinity while permitting finite creatures to dream of it. We are bounded beings whose thoughts can reach beyond boundaries. We are mortal minds that can contemplate eternity while knowing it does not exist. This is not tragedy. This is grace. The finite universe gave rise to us, and through us, the finite contemplates the infinite, forever reaching toward what it can never become, forever wondering at what it can never touch. Look up at the stars tonight. There are not infinitely many of them. This makes each one precious beyond measure.